Variables in a scientific investigation. This lesson is about the variables or factors in an investigation that can change. Remember that every investigation starts off with a hypothesis. This is what you're trying to find out. Usually this is stated in the form of a question or a statement. The independent variable is that one factor that you will change in the investigation. This is what you're trying to find out about. The dependent variable is what you're trying to measure. This is the second thing you're trying to find out about. And the control variables, these are the other factors that you're going to keep the same so that the investigation is repeatable. In other words, you can carry out the same investigation and come up with similar results and a similar pattern, and reproducible so that other people can follow your method and come up with similar results and see a similar pattern. Now remember, every investigation, it will also need a risk assessment. Remember, health and safety is king. So you need to find out what the hazards are going to be in your investigation and the safety procedures that you're going to use to minimize those risks. So before we begin, take a look at this young lad here. What two things has he done to carry out a risk assessment and the safety procedures he's put in place to make sure that he stays safe during the investigation? All right, in this next video, try to remember all these things and we'll come back to it.
It's estimated that each year in the UK, over 100,000 people will be injured from slipping on a smooth surface in the home. Makes the home seem like a pretty dangerous place to be. And let's face it, kitchens and bathrooms are full of potential hazards. It only takes one catastrophic spillage of baby oil and it could all be over. So we decided to investigate which commonly used household oil is the most dangerous. First task, to turn this hillside into a Brainiac testing zone. All that's required is some long rolls of polythene and a scientific measurement to base our readings on.
25 meters!
The bales of hay will act as a set of brakes. We're testing 3 oils today: cooking oil, cod liver oil and baby oil. Ordinarily, being coated and rubbed down with baby oil would be a pleasurable experience, but not when you're a Brainiac. To ensure maximum slipperiness, we also spread the baby oil on the polythene sheet. Time for test run number 1. Brainiac travelled the 25 metres in 7 seconds, giving an average speed of 12.9 kilometres per hour. Next up, cod liver oil, and to avoid cross-contamination, we replaced his suit and greased him up. As with each test, oil will be placed on the track as well as our Brainiac. Cod liver oil is well known for oiling your joints, but just how slippery is it? The answer, obviously, not very. Cod liver oil is a complete disappointment, and as our Brainiac did not reach the 25-metre mark, it gets the big DNF, did not finish. The third and final oil to be tested is found in most household kitchens. It's cooking oil. 12.9 k is the speed to beat. Will the cooking oil be able to handle the heat? It sure will. With an average speed of 18 kilometres an hour, our Brainiac experiment has found a clear winner. So next time you head for the frying pan, make sure you use extreme caution when handling the oil.
All right, what did we learn from the Brainiac investigation? Well, first of all, the hypothesis. You could have stated that as either which oil is the slipperiest, in the form of a question, or in the form of a statement, the oil that is the slipperiest. What was the independent variable? What was the one thing that they changed? Well, it was a type of oil. Remember, there may have been 3 oils, but the one thing they changed was which type of oil they used. The dependent variable was the slipperiness. Now remember, there's no unit for slipperiness, so the Brainiac investigators decided to use the sliding speed, or how quickly the guy in the suit sped down the slide, as a measure of how slippery the oil is. Then we have our control variables, the things that they kept the same so that the experiment could have been repeated again by themselves, or another group, say the Mythbusters, could have reproduced similar results. Now, they kept the same guy sliding, they used the same type of plastic suit, they used the same slope on the hill, and they kept it to the same sliding distance. Now, how did they make sure that there was safety in place during the investigation? In other words, there were risks involved, and how did they make sure that everyone stayed safe? Well, they identified the potential for crashing injury, and they prevented that crashing injury by putting in some hay bales at the end so that the guy sliding could land on them safely. Any potential eye damage to the slider was prevented by wearing safety goggles. Now, remember, you will have to carry out a risk assessment for every investigation that you carry out, including the ones on the exam. And this concludes this lesson.